Welcome to another episode in our trigonometric saga. In this episode, we're going to look at right triangle trigonometry. We'll start by looking at the regular trigonometric functions, and then we look at reciprocal functions. Special angles are next, and we will end this video by looking at what are known as the cofunction identities. The trigonometric functions are defined in terms of the sides of a right triangle. So here we have two right triangles, which are pretty much identical. For every right triangle, there is a well-defined hypotenuse. So there are two ways of defining this hypotenuse. It's the longest side of a right triangle. It's also going to be the side that is opposite the 90-degree angle, the right angle. So remember these two, right? You may find yourself in a situation where you can't identify which side is the longest, but you can easily see which side is opposite the 90-degree angle. So that side will be the hypotenuse. We have two sides left to define. Well, these definitions are now relative. It depends on the angle in question, the angle that you're focusing on. In this case, if this is the angle, then this side will be opposite to that angle and is going to be called the opposite side. And this side will be called the adjacent side. However, if this angle were the angle of focus, as over here, then this side that was here called the opposite side is now going to be called the adjacent side, and this side obviously is going to be opposite to this angle. In this video, for the most part, we'll be using the symbol T to represent the angle for no particular reason. So remember that for every right triangle, the hypotenuse is well defined. However, what is opposite and adjacent will depend on what angle you're focusing on. In this case, this is the opposite side. In this case, this is the adjacent side, and this is the opposite side. There are three fundamental trigonometric functions that you need to be very familiar with. The first is the sine, and it's defined as the ratio of the length of the opposite side to the length of the hypotenuse. So notice that in this case then, the sine of this angle is going to be the length of this side divided by the length of this side. However, over here, the sine of this angle is going to be the length of this side because this side is not opposite the angle. And of course, the hypotenuse is the same. The cosine of an angle is defined as the ratio of the adjacent side to the hypotenuse. So in this case, this is the adjacent side, and in this case, this is the adjacent side. The tangent of an angle is defined as the ratio of the lengths of the opposite side to that of the adjacent side. So here, the tangent of this angle is the length of this side divided by the length of this side, while the tangent of this angle here is going to be the length of this side divided by the length of this side. If you have difficulty determining which side is the adjacent side for a given angle, first eliminate what is the opposite side. So in this case, the opposite side is the angle that's right across. So imagine this as an eye, and what side is the eye looking at? Well, it's looking at this side, so that's opposite. So then you're left with two adjacent sides per se, but one of them is always going to be the hypotenuse. So this is officially the adjacent side. Likewise here, imagine this is an eye is looking at the opposite side. Leaves you these two sides. One of them is the hypotenuse, and you know which one is the hypotenuse because it's opposite the right angle. So then this one has to be the adjacent. Make sure you know these functions here. Sometimes students find this mnemonic to be helpful, SOHCAHTOA. So that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So it is very important that you become very familiar with these functions because they form the basis of everything we're going to be doing moving forward. Often the right triangle will not be oriented as we have here. So let's look at this example here. Here we have a right triangle. This is the 90-degree angle. That makes this side the hypotenuse. So let's look at these angles. For this angle, this is the opposite side and this is the adjacent side. However, for this angle, this is the opposite side and this is the adjacent side. So it is very important that you be able to identify the opposite and adjacent sides for angles in right triangles, regardless of their orientation. Let's look at these exercises here. So we're given this triangle and we're asked to find the sine, the cosine, and the tangent of the angle alpha here. So the sine of alpha is going to be equal to the opposite over the hypotenuse. So that's going to be 8 over 17. The cosine of that angle is going to be the adjacent over the hypotenuse. So that's going to be 15. You can use a calculator to get these in decimal form. The tangent of the angle is going to be the opposite over the adjacent. So that's going to be 8 over 15. If you come down here, so now the sine of the angle T is going to be the opposite over the hypotenuse. Notice the opposite now is 7. So that's going to be 7 divided by 25. The cosine of T is going to be the adjacent, which is 24 over 25. The tangent of T is equal to the opposite, which is 7, divided by the adjacent, which is 24. And so there we have it. Finding the sine, tangent, and cosine of angles in right triangles should be no problem at all. For each of the basic trigonometric functions we looked at just now, sine, cosine, and tangent, we have the corresponding reciprocal function. So the secant is simply the reciprocal of the cosine function. The cosecant is the reciprocal of the sine function, and the cotangent function is the reciprocal of the tangent function. Note that the cosecant function is the reciprocal of the sine function, not the cosine function. The cosecant function is the reciprocal of the sine function, and the secant function is the reciprocal of the cosine function. So the secant then is going to be equal to the hypotenuse divided by the adjacent side. The cosecant is going to be equal to the hypotenuse divided by the opposite side, and the cotangent is going to be equal to the adjacent side divided by the opposite side. Here are some more examples. So for this one, let's find the sine, cosine, tangent, secant, cosecant, and cotangent. So the sine is going to be equal to the opposite, which is 4, over the hypotenuse, which is 5. Now the cosecant is going to be equal to the hypotenuse, which is 5, over the opposite, which is 4. So notice they're reciprocals of each other. 4 over 5, 5 over 4. Let's look at the cosine of alpha. Cosine of alpha is the adjacent, which is 3, over the hypotenuse, which is 5. Notice the hypotenuse is opposite the 90-degree angle. This means, of course, that the secant then of alpha is going to be equal to the hypotenuse, which is 5, over the adjacent, which is 3. Notice again, they're reciprocals. 3 over 5, 5 over 3. The tangent of alpha is the opposite over the adjacent, which is 4 over 3. And the cotangent of alpha is the adjacent over the opposite, which is then 3 over 4. Now let's look at this example here. We're to evaluate all these functions. So the sine of t is going to be equal to the opposite, which is 33, divided by the hypotenuse, which is 65. This means then that the cosecant of t is going to be 65, which is the hypotenuse, divided by the opposite, which is 33. Again, notice reciprocals. Cosine of t is the adjacent over the hypotenuse. So the adjacent is 56, and again the hypotenuse is 65. And of course, the secant then is going to be 65 over 56. The hypotenuse over the adjacent. And the tangent of t is going to be opposite over adjacent. That's going to be 33 over 56. And the cotangent of t is going to be the adjacent, which is 56, divided by the opposite, which is 33. So with a little bit of practice, you should get this. This should not be anything difficult at all. We now come to the special angles. So what makes these angles special is simply the fact that it's easy to remember their sines and cosines. So you don't need a calculator. Consequently, many problems are written in terms of these angles here, so that you can figure out the answer without having to use your calculator. So the special angles are 0, 30, 45, 60, and 90. And you should memorize at least these two columns here, the sine and the cosine of these angles. Remember, the tangent is simply the sine divided by the cosine. So initially this might seem like something hard to remember, but there's a pattern here. 0 can be looked at as the square root of 0 over 2. 1/2 can be looked at as the square root of 1 over 2. Obviously this is the square root of 2 over 2. This is the square root of 3 over 2. And this can be looked at as the square root of 4 over 2. And then a cosine is the same list, but just runs the other way. Notice 1, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2. So if you can remember 0, 1, 2, 3, 4, you can remember this, because it's the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Remember, square root of 4 is 2, and then 2 divided by 2 gives you 1. And then this is the same list, but in reverse. So you should remember that the sine of 30 is 1/2, the cosine of 60 is 1/2, and then the sine of 60 is root 3 over 2, sine of 45 is root 2 over 2, or 1 over root 2. Then the tangent, well, you can always get it by just dividing sine by cosine. Okay, so that's it for these special angles. Finally, we get to look at the cofunction identities. So let's look at this triangle here. Let's label this side here H. as that's going to be the hypotenuse. And this side, let's call it P, and this side, let's call it Q. Now notice something here. The sine of alpha is going to be equal to P over H. What's the cosine of beta equal to? Well, the cosine of beta is going to be equal to the adjacent, which is P over H. So what do we notice here? The sine of this angle is equal to the cosine of this angle here. Note, it's also going to be true that the sine of this angle is going to be equal to the cosine of this angle. So you can check that out for yourself using the same approach. Now, something very important to note about these two angles here is that the sum of these angles is 90 degrees. How do we know this? Well, because for all triangles, the sum of the angles is 180, and of course, since this is already 90, that means 90 degrees has to be shared between these two. In other words, alpha plus beta has to be equal to 90 degrees. So in general then, if two angles add up to 90 degrees, they are said to be complementary. So that's what we have here. And the sine of an angle is going to be equal to the cosine of its complement. That's what we just established here. So one way of writing this a bit more formally then is to say that what the sine of an angle is equal to the cosine of its complement. And what is the complement of an angle? Well, 90 degrees minus t. So here we have it in radians. But this would be equally true in degrees if I wrote 90 degrees. Only that this t would have to be in degrees also. So notice the sine of an angle is equal to the cosine of its complement. And what's its complement? It's 90 degrees minus that angle. So the complement of this angle is 90 degrees minus this, which is this. The complement of this angle is 90 degrees minus this, which is this. So please don't just memorize these formulas by rote. Sine of t equals cosine of pi over 2. That's very hard to remember. Sine of an angle is equal to the cosine of its complement. The cosine of an angle is equal to the sine of its complement. And the complement of its angle, and the complement of an angle is simply 90 degrees minus that angle. So the complement of 30 is 60. The complement of 20 is 70. The complement of 85 is 5. The complement of 2 is 88, and so on. Sine of an angle is equal to the cosine of its complement. The cosine of an angle is equal to the sine of the complement. So don't memorize these things by rote. Make sure you understand the meaning. Let's look at the tangent now and find its cofunction. So once again, let's call this h, this side p, and this side q. So what's the tangent of alpha? The tangent of alpha is the opposite, which is p, over the adjacent, which is q. Now what's the cotangent of beta? Well, the cotangent of beta is the adjacent over the opposite. Remember, the cotangent is the reciprocal of the tangent, so it's the adjacent over the opposite. And so that becomes, again, p over q. And so we see then that the tangent of an angle is equal to the cotangent of its complement. The tangent of an angle is equal to the cotangent of the complement of that angle. Now remember, to find the complement of an angle, it's simply 90 degrees minus that angle. Okay, so that brings us to the end of this video. Thank you for your kind attention. See you in the next one.